polynomials. When you multiply polynomials, what you end up doing is distributing. You kind of look at it this way. You go, okay, you could write them in any order you want to, but it's always easier to put the fewer numbers out front. Like this first parenthesis only has 2 terms, the second parenthesis has 3 terms. And if you remember what you have to do, you have to say, okay, first I'm going to take the x, and I'm going to multiply it by all these terms over here. So x times x squared would give me x cubed. X times negative 2x would give me negative 2x squared. X times positive 8 would give me a plus 8x. But now I got that done, I got to multiply everything by negative 11. Negative 11 times x squared is negative 11x squared. Negative 11 times negative 2x, and negative times a negative is going to give you a positive. 11 times 2x is going to give you 22x. Okay, and then negative 11 times a positive 8, and negative times a positive is a negative. 11 times 8 is 88. We don't leave it like that, do we? We have to clean it up. We want to put all the like terms together after we multiply it out. So if I get to looking, I'll kind of color code this. There's only one x cubed term. We always write the term with the biggest exponent first. That's called putting it in standard form. No more cubes, so I'm done with the cubes. Now let's see, I'll pick just a different color. Let's look for x squared terms. There's an x squared term. Here's another x squared term. Negative 2x squared minus 11 more x squared. Remember what you do is you write the x squared part down. These are like terms. You write the like term down, and then you add or subtract the numbers out in front of them. So negative 2 minus 11 would give you negative 13, and we actually write that as subtract 13 when we're simplifying. And then you go, I got my squares taken care of. So now let me look at my x terms, my x to the first power terms. There's a plus 8x, there's a plus 22x. What do those add up to? 22 and 8 make 30 of those x's. You're just saying how many of each type do I have. You're not changing the exponent on any of these at this point. Though we did at the first step when we multiplied, we did change exponents. But now we're just collecting things that are alike. And the only thing I have left now is that minus 88, the constant term on the end right there. So that's what we're doing here, is we're just multiplying it out and simplifying it. Now another one I want to point out in this section that you just almost, I can guarantee you most of the class would do this wrong. I try to say it often so that maybe you would realize this. 6x minus 5 squared is not 36x squared minus 25, okay? You got to think of this as there's 2 copies of 6x minus 5 multiplied together. It's not that easy. There's 3 terms that you're going to end up with. We'll do it really quickly. 6x times 6x is 36x squared. 6x times negative 5 is negative 30x. Now if I distribute this, negative 5 times 6x is negative 30x. And then negative 5 times negative 5 would be plus 25. These 2 middle terms almost always combine here. So we have negative 30x minus 30x would be negative 60x plus 25. So many people just want to say that that's 36x squared plus 25 or 36x squared minus 25. But you've got another term there because you've got to remember that's just short notation for I've got 2 copies of those 6x's minus 5 multiplied together. If you remember on these are the easy kind because there's not a number, there's only an invisible 1 out in front of this x squared here. So these are the easy ones to factor. When you factor, if you remember, we labeled this ax squared plus bx plus c. And we said we're trying to multiply to get the constant term on the end, which is c. So that's a negative 14 in this case. And at the same time, we're trying to add to get the coefficient of the middle term, or your b term. And b is 5 here. What would multiply to give you negative 14 and add to give you 5? There's only a couple ways to get 14. 1 times 14 and 2 times 7. Which one of those has like maybe a difference of 5 in them? Wouldn't the 2 and the 7 have a difference of 5? If you think, okay, I kind of teach this a little bit differently than other people. I try to, I hope, make it easier. If I know I need to add them together and to get 5, I'm looking for the 2 numbers that have a difference of 5 somehow, if I'm going to get a negative 14, I know one of them needs to be negative. How am I going to get a positive 5 out of a 2 and a 7? Which one would be subtracted or negative? The 2. If you think about it, negative 2 times 7 is negative 14, and negative 2 plus 7 is 5. Those are going to be my factors. What I'm going to take and do with them is just put an x with each one of them. So there's an x minus 2, and there's an x plus 7, and it's factored. I don't worry so much up front when I'm trying to figure these two numbers out. I don't worry so much about which one's negative and which one's positive. I just list all the different ways you could get 14, and then if I see a negative in the equation at all, and I do, it's right here, then I know, okay, that there's going to be a negative show up somewhere in all of this. And since I'm trying to add to get 5, I'm just thinking, well, which two of those numbers have a difference of 5 if I combined them and subtracted them in some way? Well, this one did. So I put them down, and then I kind of tweak it after I get them over here and think, oh, okay, I need one positive, one negative, and I got to add to 5. Well, 7 minus 2 is 5. So that's kind of how I think about them. Some books go into a lot of detail about if it's negative, you got to do this, and if the negative's here, you got to do it this way. I think this little organizer kind of helps. The problem is, did they give you very many of those easy ones? Oh, no, they did not, okay? Now, 45 is an easier one. I'm not going to do the whole problem, but let me just remind you of something. Do you remember that when you factor, there's the first thing you should always do is check for the GCF? Before you do anything else, see if there's a GCF. That means a factor that divides out of all of them. Is there something that divides out of all those numbers?
3.
Yeah, 3. If you do that, then you got 3x squared plus 3x minus 10. All you got to do is factor the inside part. That just immediately made that an easier problem. And a lot of times they try to hide, they try to make it look harder by multiplying through by a number. So you should always check first to see if it's in there, and if it is, pull it out, and then all of a sudden that just becomes, what can I multiply to get negative 10, and at the same time the numbers add to 3. It becomes a much easier problem. You don't have to use this little diagram, but for people who struggle factoring, it can be helpful. What if it's hard, maybe they're having a hard time with? In this section, it needs to be, what about 53? 6x squared plus 19x minus 20. There are two ways to do this. If you think back to your Algebra 1. One of the ways to do this is I got to try to find, it's called guess and check. And guess and check can drive people crazy, especially on problems like this, because there's lots of ways to get 6. There's 1 and 6, there's 2 and 3, and then there's several ways to get 20. You got, well, if you want to get negative 20, there's negative 1 and positive 20, 1 and negative 20. There's 2 and negative 10, or negative 2 and 10. There's 4 and negative 5, or negative 4 and 5. There's lots of ways to combine these numbers, so it can be harder. So I don't remember what we did in Algebra 1, but there's an easier way to do this, and it involves factoring by grouping. So you're going to have to be, if you want to see a way that'll get you there every time, I'm going to show you that way now instead of doing the guess and check. I'm going to go to a new slide though. So if factoring by grouping is hard for you, you might want to look at some of those videos to get the hang of it, because one example is not going to cut it for you, I'm sure. What we can do is modify a little bit. We're going to, since this problem is made harder because of this 6 out front, so we're going to adjust for that. When we're trying to figure our numbers out, I'm going to multiply the number out front times the constant term. Let me label this so you can see where I'm getting my A and my C from. My A is 6, it's the number in front of the x squared, and my C is negative 20. What is 6 times negative 20? It's negative 120, okay? I'm trying to find two numbers that multiply to give me negative 120, and at the same time, they still got to add up to that middle number, that B term, 19. Now, if you think about this might be a little easier problem to think about than, this is the hard part of it right here. What would work? Let's list all the factors of 120. 1 times 120 is not going to work. 2 times 60 is not going to work. 3 times 40, probably not going to work. 4 times 30, not going to work. 5 goes into there, let's see, 24 times. Ooh, those two numbers have a difference of 19, don't they? If you said 24 minus 5, wouldn't you get 19? So these are the numbers I'm going to want to put up in here. And this is going to be a longer process. We're not there yet. 5 and 24, if I want to add those numbers and get 19, wouldn't it have to be 24 minus 5 is 19? Right? So if I go to factor this, this is where it kind of goes a little off, okay? And the 8th graders this year, we did this and they loved it. They hate guess and check, and they love this as a substitute. What I'm going to do is all I did here, this is going to help me rewrite this middle term. I'm going to write down my first term. Instead of writing plus 19x, since 24 minus 5 is 19, I'm going to put minus 5x plus 24x. I'm rewriting that middle term. And then I'm going to write the first and the last term. I'm just going to keep them the same, and I rewrote the middle term. Now, how is that going to help me? Well, in these problems, here's what you do. If you're going to do, it's just called factoring by grouping. Let me write that down in case you want to do a little, looking at some other videos. Because guess and check can be very frustrating for a lot of people. I'm going to group these things. I'm going to say, let me look at the first two terms together, and then I'm going to group the second two terms together, and I'm going to factor out a GCF out of each one of them, the greatest common factor. So if I look at the first two terms, what's the biggest thing that divides out of 6x squared and 5x? Wouldn't it just be an x is the biggest thing that divides out? And if I write it down and I write, here's my GCF, remember what's my leftovers? 6x squared divide out of x would be 6x. And then minus 5x, divide the x out would be minus 5. Okay? So you think, well, how does that help me? Well, let's keep going, and eventually I hope you'll see. Let me look at the next two pair of terms. What's the biggest thing that divides out of 24x and 20? Wouldn't 4 divide out of both of them? Okay, so I'm going to put 4. That's my GCF just of those two things. And after I write what's left, 24x divide out 4 would be 6x. Ooh, look, that's the same thing as in the first parenthesis so far. Minus negative 20 divided by 4. Negative 20 divided by 4 would be a negative 5. Do you notice that what just happened is I have two of the same things in the parentheses there? I'm almost finished at this point. I can say, oh, okay, that's a new GCF. So I took the GCF out of the two pairs. Now I'm going to do it again. I'm doing it for the third time. I'm going to take a GCF out because now I've got two new terms. When you have things multiplied, that's a whole term, and that's a whole term. So isn't there a 6x minus 5 in each one of those terms that I circled, right? What's left out of the first term when I take the 6x minus 5 out? X is left. And what was left over here when I take the 6x minus 5 out? A 4, and it's a plus 4. There's a plus in front of it. We just factored the problem.